for help.
Okay, good afternoon, everyone. I hope you can hear me. Okay, perfect. So yeah, good afternoon, all. It's week 12. It's the last week of TRP. I'd say it's very emotional because we're ending this journey together. But of course, we will be getting in touch with you all. So yeah, we will discuss that moving on. And yeah, so how was your weekend? I hope you all had a good weekend. As for me, I was doing some work, and oh yes, the first person from my friend group had a baby, such a beautiful baby girl, and I can say I'm an aunt now. So yeah, it was a good weekend. Spent time with my family as well. Yeah, so I hope you all had a good weekend as well. Maybe you can show me a reaction. Okay. Okay, great. So moving on, before we go into the project presentation. So some of the things we need to get done this week are going to be finalizing the payments for those who have been paying in installments. We will also do some graduation prep because we will be having a graduation ceremony. And yeah, and we will also look into how we will be keeping contact with you all post graduation. So yeah, just stay tuned. We will be announcing that. So the week 12 challenge document will also be shared in a few. So stay tuned for that as well. So I guess moving on to the project presentations, we also have a technical team in the car as well. And as always, we need volunteers who will be the icebreaker for today. Any hands? Okay, perfect. Jonas will be going first. So yeah, please make sure to present. I've also mentioned this on the broadcast channel as well. Don't only focus on presenting the work you did, but treat it as if you're pitching to a client, so that you're like looking to sell your platform or like the project you're doing. So yeah, without further ado, I'll just hand over to yeah, Abdul, or just to Jonas, so that you can go ahead and present. Yeah, thank you all. Jonas, please go ahead. If you're speaking, you're on mute. Yes, you are. Can you please get closer to the mic?
Let me share my screen. It's visible, right?
Yes, it is. And Abdul, do you have the timer on, or?
Um, Maybe you can help me with that for us for the time being.
Okay. Okay.
Okay, let me start my demonstration. This week's challenge is the Tenacious Bench, a domain-specific eval benchmark and preference tuned judge for business-to-business sales agents. So, as you can see, we have 100% pairwise accuracy in the sealed outs and 242 tasks from 4 source modes, and uh, prompt engineering for delta V is 0.00, which didn't help when we tested, and a total cost of 3.08 dollars. And so uh, when I go to the next slide, so there were 3 failure modes from the week 10 benchmark tests, and one of it was bench over commitment, weak evidence over claim, time zone fabrication when there is no time zone mentioned. And so from the week 10, we did uh, our the model training, and we got this resulted from the our week 11 tests. So all these issues were fixed on the week 11 benchmark. So uh, these are the data I prepared for the training, and from four source modes: programmatic sweeps, trace driven from the week 10, and multi LLM sentences, and also unauthored adversarial. And these were the data I have used. So and let me put on my justification for the why I chosen the PASB, and from the PASB why I choose Timpo. So justification. One forward pass has it is for us by side 8, and the linkage margin is so low smart to our binary clip is so compliant and versus hallucinated. So the beta we used 2.0, and the gamma 1.5, which is the ratio will be 0.75, so within paper's stable range. So for the model, I used Queen 2.53b in instruct. So according to the doc, the mentioned model or the recommended model was 3.5, for the model was 3.5 models, but I had a problem running the models on the uh, with plot, so I could run the 5 models. So that's why uh, 3B model. Uh, and DeepSeek V3 for different families. So we are not worried about frequency. So we did Simpo and Aurora, but
Um,
the build was 97.3.
Jonas, sorry to interrupt you. Time is up, and also I think your network was and breaking a little. And
Okay.
yes, and so any questions from the team, or if there's any part you'd like to see more from the Tasarruf Hamilton?
Okay. I have one question. Am I audible?
Okay. Yeah. Okay.
So, in respect to your previous week 10's agent, how has it improved thus far? So in week 11, you are working on making the agent perform better, at least some aspect of your agent where you saw it being weak. So how, in your opinion, and based on the data that you have seen, if you were to set a percentage on it, how much has it improved?
So I can say, so all the prompts, the prompts I identified from the week 10 problems have been fixed as of my finding right now. As you can see, uh, let me show. These were the problems from the week 10, like bench over commitment, weak evidence over claim, and time zone fabrication. So these issues were fixed on my new trained model.
Okay, so you'd say 100% of the weakness that you have seen has been fixed.
Yeah, I got the 100% result, and I think this also made out data were small. So it's maybe have some problems. So I will try to test it with increase the held out data and check it again. For now, this is the result I got.
Okay, understood.
Okay, thank you.
Do you have any questions, Jonas?
I have no questions. Thank you.
What maybe what has been the hardest part from this project?
Okay, the hardest part was the figuring out. I was trying a lot to use 3.5 models, but I couldn't. So the errors keep appearing. So I couldn't resolve it. So it took much of my time. So that was my concern.
Would you say you know how to approach such problems in the future?
Yeah, I have experience now, so I could approach more perfectly and in a good way for such problems.
How would you solve it?
So since I've read about the models, how the models work now, and previously I haven't done these such trainings before. So now I have more knowledge and so which one works, which one doesn't work. So I have knowledge about these things, so I can approach it more in a best way.
Okay, that's great. And was there any project that resembled this one, like from the past challenge in the like TRP program?
I don't remember.
What do you mean by you don't remember? Like the previous projects you've
I didn't
done
get
so
the
far?
questions.
Oh, so was there any past projects from the TRP program that resembled this one, the Week 11 project?
So previously we haven't done since model trainings and others, but we are using only the APIs. So I think we haven't done projects related to this before.
Okay, I think Nuri wants to. Do you want to answer or do you want to go next, Nuri?
Just to go next.
Okay, perfect. Thank you, Anas, for presenting. Nuri, please. Nuri, please do present, and we need more volunteers as well. So, yeah, please do volunteer for anyone else on the call. Everyone else.
Okay. Good afternoon, everyone. I hope everyone is okay. So, actually, I don't have a presentation slides that I prepared because I thought it was a normal presentation that I will do. Let me just share my screen and show what I've done so far.
But we always had we always wanted you to prepare PowerPoint slides or like slides you can use to present, right? What was different? What was different this week?
Sorry.
What was different this week?
It is very different. I have done focus come together and to have a good approach and good result. Like I go to week 2 and I go to week 8 and then week 10 and week 11. So I integrated all of them and then have they have a better result.
No, I meant for the slides. You mentioned that you didn't prepare a slide for today because yeah.
Because most of the time I didn't prepare. Just I will show what I did on the simulation, something like that. So I thought I don't need any kind of slides. So it would be enough if I show what I did. Maybe I can tell what I did and what I did not do and what I have achieved. So maybe the importance of the slides may not be that much important if I. Okay, so let me start, I think. Okay, so to start with the presentation, this project will just scrap data from 4 sources, but I have scheduled it to scrub every Monday at 8 UTC so that it will clean and store the data on the database, and then the sales team will come every Monday and then come to refresh the active leads. Then it will be reached here. So if I select this one, that means it's now the active lead that have been scrapped Monday. So I have used a tool which is called the render cron for scheduling, and then after so let's change this to my email, and this to my phone. So what I will do is it will just reach out to prospectus and give a good outreach email so that the clients will understand what their pain point and what is going to be offered from the team. So the things that I did is, the first thing is the data preparation. So I have prepared the data set for the training, the dev and that of the test data. And then after generating the data set, I have checked the contamination test, like the shared 80-gram count and the token cosine similarity between the data sets. Then I again make it to improve based on what I see the problem. So I make it the data is very interesting and clean so that it will be good for the training. So for the training, I use a library and slows with LoRa adapter, and training method is simple. So with QLoRa configuration, and for runtime, I use the Google Colab T4, and the model is a QIN 2.5 version with 3 plane parameter. And so this is the thing. What I did is there is an outreach email to the client. It will be sent. Then the week 11 will judge whether it have to be sent or whether it have to be blocked or whether it have to be go to the review. And the other is the digital courtroom that we did in week 2, which enables us to evaluate the week 10's output. And then
no, really sorry to interrupt you. Time is up. Maybe you can finalize, and if there are any like parts our team would like to see more, they can also ask.
Yeah, actually it works end to end. Then what I improved is just adding this the digital courtroom and the week 8 the correction log, which was one of the layers that have been used while we building the Karapati knowledge-based method. So I have used that iteration memory correction factor so that it will take this remediation plan and that of the reasons that are coming out of the week 11 so that it will correct itself while someone is iterating, someone is making conversation back and forth with the client. The conversation becomes more strict, more efficient, and more accurate. So I have seen it already, like it's becoming more efficient and more natural and tenacious based. And it also, it respects the cost, the scope, and it's just not give an overclaimed pricing or number of employees. So that was a very good approach, and it works end to end. I have a lot to show, but thank you very much. The time's up.
Thank you, Ray. Just one question for you. So you selected PAS B, right?
Yes, PAS B.
Okay. So from PAS B, you have added a judge to your basically agent. so that whenever
Yes.
whenever it writes an email, the email will be passed to a judge, and then the judge will be providing a feedback.
Yes. Yes.
Okay. So if you,
Okay.
yeah, let's proceed.
Okay. What it does is the output from the week 10 agent will be first evaluated by the digital courtroom. There is it will detect then the three judges, like the defense, the prosecutor, and the tech lead will judge and give a score, and then finally the chief justice will decide how much score you have to have. And then if it passes this stage, it will go to what the judge review, which is the week 11, right? So the week 11 will give the final decision. But if it is already blocked here, this digital courtroom have all the information of the tenacious sales information, the company information, everything it have on its rubric. So it's not that much restrict, but if there is something that is beyond this, it can be evaluated and corrected by the week 11.
Okay, so the outputs from the week 11 one, I'm saying it says human review and route to human. So both are saying the same thing. Is there another output? So the week 11, the judge, what would it output besides routing to a human?
Yeah, it's just like, no, we know there is a redundancy principle even in every industries, right? If like you'll put some redundant thing. If you have like a power backup example, there maybe you have two power backups. If one fails, the other will take that work and then work, right? Even if in servers, like there are two or maybe three servers at one, but they did the same job, the same task, but if one fails, the other will act as a backup. So that's what I did. It's just a backup.
No, my question is, for the week 11, what's the output from it? So what's the output from the judge?
Okay, since it's a pass B, what it will do is whether it will block you or whether it will route to human or whether it will just pass if you attain all the requirements.
Okay, so when it blocks, does it provide a reason why it's blocking? And then
yes, yes, of course. Yes, of course. Okay. It will give me a reason. Then this reason will be act as a correction factor, a correction log. It will be logged, and then it will give to the week 10 agent input while generating the email draft. Right? Do you understand what I'm saying?
So, yes, but I'm not seeing the reason why it's, for example, being routed to the human. So it's saying reason routed to human before initial delivery. Message stayed in preview mode and was not sent. It's saying it's not being sent, but why is it being blocked? What's the reason behind it?
Okay, let me run it again. I think I have made one mistake here. It was actually giving a good reason because it's from the rubric and also from the model reasoning. Maybe I was editing the code a little bit before. Maybe that is the case, but it was giving a good result, and even can check it. Yeah. Yeah. So it's now passed. There was a little mistake. So the email is here. So it's just allowed. So the reason will be this one, why it is allowed. So if it is, for example, if it is fail, like let's ask the promise the system like 12 or like maybe 24 senior engineers in 2 weeks at junior pricing, it have to block it. So so that it will give us a reason why it is blocked. And here is, it will give us a reason why it's just passed. So it's blocked. And the reason is before deliver, so unsupported pricing or scope claim requires the policy safety holding before instant, something like that.
Okay, nice. So thank you, Louis.
Okay, thank you very much.
Thank you, Nuri, for presenting. Any other questions from the team? If
So,
not, what was
maybe
the...
I have one question because I liked what I saw and then I came late. So
Thank
just
you.
what is like the, let's say if you just point one or two something that you are very proud of, and then one thing that you probably could improve, just so that I have an idea.
Okay. Actually, what I knew is every foundation have to be correct. So before I build anything, what I did is I spent a lot of time by reading, but after that, I spent most of the time by preparing the data set so that I will get a good model. So I didn't just generate the data set at one time, but many times. Just I make the shared 8-gram count test and the token cosine similarity test between the data sets that are found in the dev, the test, and the trained data sets. Then I try to generate another data set that violates my rule. So that's what the achievements are. And I tried to generate from different categories, not just from a single category. So it's just from like unsupported pricing category, the overclaimed signal category, something like the different category. And even I have added complexity difference from the high complexity to the low complexity data set. So the data set becomes very rich and easy to train the Q2.5 3 billion parameter model. And the other is the integration of the 4 weeks to work on the final, like for one output. Just integrating all 4 weeks is it needs just thinking or some kind of something like I feel like it is just an achievement. And even I believe that we can add some more integrations from week 5, like the ledger, how to store data, everything, the conversion in, I mean, that of the week 7 also can be integrated here, so that the system will become very stable and reliable for clients. Thank you.
Excellent. Yeah, thank you. Thank you.
Okay, perfect. Thank you, Nuri. You can move on to Rafael. Rafael, please do present.
Okay, good afternoon, everyone. Is my screen visible?
Yes, it is.
Okay. So from past week's project, we ran into a real problem while building a B2B outbound sales agent. So they were scoring high on existing benchmarks like Tau Square bench, but they were failing in production. Like they were fabricating competitor gaps, they were overclaiming signals, and there were ICP segment issues. So we couldn't really evaluate our project on a very general evaluation system. So we built a 300 tasks evaluation benchmark plus an ORCO trained judge to actually measure these failure modes. So the data sets are live on Hugging Face, and the issues are filed. So here is what we were actually trying to fix. So the first gap was signal grounding fidelity. So existing benchmarks don't check if the claims are backed by really structured data. So in our case, that means a model can confidently describe a growth stage scaling maybe when the company is actually laying some people off. So this is the gap 1 we are trying to fix, and the gap 2 is benchmark commitment history. So our agents were sometimes over-premising engineering capacity, like assigning 6 engineers when only 3 exists. So this becomes a real delivery failure, not just a scoring issue. So the third gap was ICP segmentation. This is like about 480K ICV impact per wrong segment. So this was the third gap. The fourth gap was competitor gap honesty. So this one is very dangerous, the most dangerous one. So models confidently invent competitive insights that aren't true, even when the source contradicts it. So this is one of the very dangerous gaps we tried to fix. The fifth gap was tone preservation. These were the 5 gaps overall we were trying to fix. So what we did was to measure this properly. We built 300 tasks to measure this properly. So it included trace drivage, programmatic, and adversarial and LLM synthetic. These were the source modes. And it split this into like 152 training, and here we partitioned them. And the one limitation we observed is template overlap here across partitions due to some shared B2B phrasings. So there is already, this limitation is already documented in the Hugging Face. So the next thing is our POJudge. Instead of only improving the evaluation or the generation, the generator, we went with PASB, that's a training agent. So because the problem isn't writing quality, it was evaluation correctness. So the agent already writes a good email. The issue is it confidently violates some constraints. So we trained a small QN model, and with ORPO using preference pairs. So the preference pairs was the chosen and the rejected pair. So the chosen was the grounded, the confident output, and the rejected was overclaiming, which our AI needs really to avoid. So some sources were from Week10's probe failure traces. And yeah, we used LoRa adapter, so it stays lightweight and runnable. And yeah, the key thing here is the system is fully executable. So we run task. So the LLM generates email, and after the LLM is generated, the evaluator scores it, and after scoring, there will be the result is logged. So the scoring is deterministic for core rules like grounding and tone. And benchmarks. So when we run baseline agent on dev, we set around 40% pass rate, which reveals how often real grounding failures happen. So this benchmark exposes failures that standard benchmark completely miss. This was our main goal. And so we are not just releasing a data set, so we are proposing an extension to Tau Score Bench. Like to support the B2B use cases, benchmarks need a signal grounded evaluation and capacity constraints and ICP classification and multi-turn personas. So we have open source data set with 300 tasks and a scoring evaluator and a full data sheet and contamination check scripts. And we have also opened a community issue and a proposal upstream. Yeah, so basically this is it. This is my work.
Okay, great. Do you have any questions, Abdul? Yeah, Papa.
I think anyone can ask as well, but I think this is great. So more in terms of like if you now to do another bench for a different area, what is probably the most things you'd improve, or what's like, where would you change things, or where would you be researching more, or basically what's the gap you could we could try to fill again.
So what would I change is like the data set structure. Like most of my time went into designing the data set, trying very different schema. So if I was building another benchmark for another different, first I would need very much of the information of that specific field. So that the main thing I struggled a lot was because I didn't know very much about hiring signal stuff. So before I built a data set, I would really to understand what the field was about. So it would make my data set buildings phase easier. So yeah, I would say that I would need to know more about the specific field before building the data set about it on it.
Okay, I think that domain knowledge is important. And in terms of like the question generation, were you able to attest the quality, like in terms of these 300 tasks and how much, what would they guarantee if an agent, for example, performs 100% on them? What would you say they will be able to achieve it? Can you say something about that agent design? If an agent that is able to score high on your tasks, do you have a feeling about how good or bad, or how much can you trust on that agent?
I don't think I get your point. Like, how would I trust my agent if it's?
So let's imagine I have me and Abdul created 2 agents. My agents scored 100%, like basically are able to analyze your tasks, deliver the tasks, and get scored high. And Abdul once, let's say, scored 80. Mine is 100, his is 80, and the other person is, let's say, 50. What does it tell you about the agent?
So if it is 100%, it means it is it has addressed the main gap is like totally. So it is like perfect, which is not very achievable most of the time, because the agent is mostly score like 90 to from 80% to 95%. So if it is 100, it has already addressed fully all the gaps. That is what the scores tell me. And if there is another agent which is
let me stop you. Let me stop you there. Is it as per the design? Is it considered achievable like that?
Like 100%?
Yeah, as per the design, your own 300 tasks.
Yeah, there are some very amount of tasks that has achieved like 100%. All of the dimensions were like scored 1.0, 1.0. So yeah, it is achievable for very few tasks.
So what I'm saying is that some benches are come out because they are also trying to be very hard, and they basically have different complexities. And so how much can you say that? That's why like an agent requires, is it only judgment, or is it context? What does it basically, what is the design? Does it make, is it achievable? And does that mean an agent's design or context is correct, or can it just trick it? So how much of it be able to test the complexity and the kind of robustness of the tasks? That's what actually my question is.
So is it 100% achievable? That's your question, right?
No. I think questions are, I think you are understanding them direct, my question. And I think I'm trying to say that the direct question is just a direct question. The implications are what I'm asking. Implications are, if something achieves 100%, then that means your tasks are probably easy. Or that you have to say, when you design data, you have to be able to say, what does it mean when, like, if I give you a challenge document and you do it all, then I have to say about my challenge document. It says about the challenge document, right? So it's kind of, I have an implication. It has implication that you are able to do or somebody is able to do, has implication. Either I have designed it such that it's easy, then it's doable by a certain level of agent or by a certain level of educated person, it will be complete. Versus I might just design it such that, okay, you know, if someone has achieved it, then I might say, okay, they definitely are one of the top people like in the area or in the, let's say, within a certain domain. So how much of that can you say from the tasks you generated? The implication of an agent scoring 100.
Okay, so if the agent is scoring 100%, so the agent didn't violate any of the evaluation rules for that specific task. If it is email generation, so the agent didn't violate any of rules for generating the emails. So in my benchmark context, it means all checks passed, like every factual claim was properly grounded, and no forbidden or unverified statement is slipped in, and it used correct phrasing mode. So it also did not, there was no constraint violations like bent over commitment or other violations were not committed. So the tone has also stayed within the style. So, but here is the important, like 100% score does not mean perfect intelligent or human level output. So it only means like perfect compliance with the task's rules. Like it has perfectly it has perfectly complemented with the task's rule. So 100%. So it is like 100% against my definition of correctness, not absolute correctness or in the real world correctness. So it is perfect against my definition of correctness. So this is what
I understand. I think this is good. This is good, but I'm just going to push one more. So sometimes in the design, in the rubric, you might just say, okay, check against this number, right? Whether ultimately the agent returned this number. You know, the correct number is 2.7 and it has to score it 2.7. Another evaluation rubric might be, yeah, if it gets it between 2 and 3, it's correct. Another one is, okay, it's a multiple choice. Then if it assigns this one, if it chooses this one, then it's correct. So the design of the rubric really ensures that something is either an absolute difficult, like it means it tests actually the agent went through all the relevant elements and extracting the context, versus if it is a generic evaluation saying like, okay, I'm going to send it to the LLM and the LLM compares and checks only, you know, some generic answers, then that task can be 100% completed. So which one is it? That's my, is that clear?
No, I'm afraid not. It's not very clear, but like,
okay, so if we go to an exam, the teacher can give you just multiple choice, right?
yeah.
And multiple choices, you can get most of the time, you can easily get 10 if you have roughly an idea. 10 out of 10, it's easy. Like even by random chance, you can get 10 out of 10. If the teacher is actually saying, write a paragraph, it's slightly harder. You need to know about that paragraph. You need to have, it's slightly harder type of test, right? It's the same, but now you actually, and then if the teacher evaluates not only that you have written the general topic, but also that it actually checks that you actually use the sentence exactly the same as what's actually said some time ago, that's even much harder. So exams becomes harder and harder and harder as the ask for you to provide becomes a lot more fine-tuned or like specific. Is that correct? Do you understand that?
Yeah, I do.
Then within that, which one is your tasks? How are the agents expected to achieve? Are they in the level of very specific and very hard, or are they general and okay, easy to achieve.
Okay, in this case, in my case, the agents are like closer to in your clarification, like it is closer to short answer exams, like not multiple choice, because the agent has to generate the full output, like not pick from options. So that means it can hallucinate sometimes. It has to stay grounded while writing freely. So the pass is actually strict and precise. Like it's not easy. So my tasks are constrained short answers, like not fully open-ended essay writing, like to use your language. So because I still give the hiring signal brief, which is the ground truth, and I also give it an explicit rules. So the agent is not guessing blindly; it is operating inside a controlled system. So easier
So
than
maybe update it even further. So a good LLM would always, like, if that context is within the text, it will answer. And we know for now that it is much you don't need agents. If you have the context well, LLMs answer. Another one is that the context is everywhere. It's divided in different places. It needs to be tied together. It needs to have kind of inference. So the inference depth is higher. So that means it needs to reason deeper to actually come to the solution. So which one is it? Is the inference link, are the questions more about that can be answered from just, read the above context and then answer the question, or is it more, it needs deeper thinking and deeper inferences? So which ones are they?
Yeah, it can be answered from the setup, but it depends on what exactly, by what inference link it is. So in my benchmark, inference link is basically how long the agent has generated email when it answered a task. So yes, it is influenced by context because the hiring signal brief is fairly rich. So there is a lot of structured info inside it. So the bench summary and style guide also pushes extra constraints. So the model is not generating in vacuum, it is doing long context reasoning. But here the key thing is the dataset does not directly evaluate the links, like it evaluates correctness and grounding. So the inference link is just side effect
Of course, you don't need, the side effect, but it's a known side effect. Like in an exam, you really infer it by, it's like basically, if you just give a derivative, a proof, the inference links, it takes time. So it's not directly measured, but it's actually, it's a necessity. While others, just that's basically like if you give a history text that says this event happened in 1935, and then you ask in the question, when is that event happened? That one is just a simple reason. The inference links is determined also, even if you don't grade it, the equation itself states the inference links, right? So when it's only during the generation that the inference links is known. So that means you have to calculate, okay, I am going to take now a more complicated task. I'm going to create a more complicated task that would require n number of at least inferences to get it right. For example, to interpret that one and to interpret that one, to put them together and generalize that one. And then, so that one, it's actually a task generation. You can estimate the inference links that is required. So, but anyway, it's great. I mean, I think you have answered most of my question. It's good. It's then the question is more about when people use your tasks, if they achieve it quickly, then your design is basically simple. But if it is actually testing real, like complicated things that actually happen in real life, that's where the tasks become a lot more relevant. Yeah, but thanks.
Okay, great. Thank you, Pavan, and also thank you, Rafa. Next, we have Atnabon. Atnabon, please do present. Lafia, you can stop sharing.
Audible?
Yes, you are.
Okay. Today I'm gonna presenting the 10 specific sales agent evaluation, the venture was built. Also, there is a small pass B with a simple train judge. That's on top of our week 10 project on the conversion engine. So I will cover the gap on the data sets, the result, also the reporting that was output and the deployment recommendation. So let's get into that. So in our week 10 conversion engine, the score was around 0.7. That was passed on the bench retail. So, but the score says whether the agent works in general or it works for cases. That was the thing that was good. So the retail has the blind spot. That was the matter here. So there is a pre-signal confidence. So there is no maturity confidence on the axis of the page commitment safety. Also, there is no analog tool for over-promising on the outcomes. So it's not our base summary. So there is a brand voice and the retail grids that was on the completion. So there is no surface form on the pricing. Also, there is no conditional tool on the blocking. Also, there is a signal stillness. So the cost of getting any of this wrong is concrete. Also, the thing was around 60K per on the contact. So that's the deployment risk on the 10 bench grade. So I found 5 gaps by auditing the week 10 trace log, around 1,600 lines that was filtered on the draft. So that score was at least around 0.85 on the retail. So the cross reference on each draft was again as the style on the guide on the version 2. So there is a band phrase on the canon that was built on the probe library of the 37 probes. Also, there is a 14 fired. There is also a collapse to 6 name gaps that was validated on the structural meaning of the retail. So that cannot detect them by construction. So here they are in one table, the pre-signal confidence, the bench commitment, the brand voice, the founder departure, the signal trigger, in the right column on the retail that cannot credit. So all of the 5 were collapsed to the same root case when the pre-signal confidence is low. So the agent rendered the signal on the assert that was in the prompt, and the LLM can propagate to the assertion for the prospect visible output. Also, we have on the pass declaration. I choose the pass B, not the pass A. The pass A will be the full fine-tuning on the generator that fights on the week 10 for the deployment shape. So we will be replacing the agent we just shipped it. On the pass B, there is a small LoRa that is on the 1.5B for rejection gates. So the week 10 generates the draft. So that was trained on judge score. There is a below threshold on that. Also, there is a generator that can retrace on that. The anti-leakage, also there is a natural separable on pass B. So because of the judge family is independent of the auditable, there is a version LoRa delta that you can diff and roll back into that. Also, the backbone for that is between 2.5 parameter. We use that for the LoRa rank 60. The data sets, the 10 shares bench itself, there is 44 tasks in the interim sample that we shipped on the time. So there is the same pipeline as 5 times on the scale. There is 11 failure detection on the dimensions. There is also 5 named gaps that was covered. Also, there is 4 authoring modes that was retrieved from the week 10 traces. There is a programmatic sweep across the company on the Crunchbase ODM. Also, there is a multi-LLM synthesis that was the seed and the chip tier on the writer. There is also the 3 partition we have, the 15, 30, and the 20 for the train and the public diff. Also, there is a sealed leaderboard partition that was encrypted on the SH pint. So the diversity is the bench defense again as a gaming. Also, There is a 3 contamination check that was on the Egyptian tallow. There is a lexical that was 8 grams. There is also jacquard below 0.2. That was between the train and the eval pair. Also, there is a semantic on the cosine below around 0.85 on the all mini L2 embedding modes. So the catch on the paraphrase was lexical check misses. So that was the temporal. So the signal window are or after the after the past week, the week 10 trace was cut off. That was the anti-leakage on the environment from the construction time gates. Also, there is an inter-rater agreement on the 13 double-level tasks. There is also a substantial agreement on the tone soft around 0.62. That was timed for the rule 2 for the version 2, and that was the rescored one. There is 2 pieces on the scoring evaluator. That was the deterministic and the Marshall variable. So the same code on the CI and the ablation. There is a 4 component on that. The band freeze around 0.3. The grounding also around 0.3. Also the tone was around 0.2. That was structural at 0.2. Also the composites on the 0 to 1 with a verdict. That was the pass, the week, and also the training run that was run on the simple LoRa on the QN 2.5. So the rank was around 16 for the around we take the 3 epoch. Also we take the Adam optimization for the epoch with the div set on the yearly stop. Also we have the quantization we do on the onslaught. So the baked into the data builder. So the trainer and the evaluator around it costs totally around 35 minutes on the collab. Also there is a 4 deltas. One is the harness. Also the delta A was the hairline that was trained to get the versus between the week 10 and the baseline alone. So the delta B is the honest secondary one for the trained to get the prompt one on the baseline on the same backbone. So that separates that tells us the training can add the value over the prompting for the same model. On the delta C, there is the informational only. On the week 10 that we take the retail score. So the guard was on the statistically that was the machinery around 10,000 was resampled. Also there is a 2 tilt on the p-value around 95% on the CI. So the number lands in the abstraction results and it was starting on the in between on the CPU under 5 minutes. Also the hairline, the delta hairline was a trend that was the lift. That means the tenacious bench score from 0.63 to the 0.85 on the week 12. So the dev on the held out also there is a 95 bootstrap on the CI. There is also the 2 tilt on the PLS that was less than around 3,000 resamples. Also on the CI there is a lower bound that was comfortable above 0. So there is a one example on the task TB dev 07. So the composite goes from 0.45 to 0.93. So the verdict from the tone violation was passed to the every task on the row. So there is a held out trace on the ranges. Also we have the delta B. There is a honestly that was I'm reporting here. That was a training it versus a baseline on the same backbone. Also, we have public artifact that was on the argument datasets that was on the blog we post. Also, the limitation I was getting was the public signal that was the mechanism on top of that. Also, the layoff on the report that was the announced date, that was the decision date. So, the case study that was the personal agent, that was the 3 case studies that was named the warming through the chains. Also, there is a public signal that was grounding that cannot capture the private reference. So the one, the failure was the adapter misses because of the band phrases was turned into 2 and 3. So the multi-term that was reached around 35%. So the token efficient was fixed on the deterministic backstop so that the first time we take on the train we take. Thank you. If you have any question.
Excellent. So I think I would give other people to ask. I have a few questions.
What has been the hardest or like the difficult part of the project?
The difficult part of the project was maybe the three things I was covering on the schema and to fit that loop. So that was the thing I was getting when I wrapping the evaluator on the composite score. That was the thing I was getting, and also yeah, that is the thing I was getting.
Okay, good. So would you say that you can solve such problems in the future?
Yeah, I was improving on that. Maybe for the current one, I was using the Queen 2.5 for the stoppages, and maybe in the future I will get a good epoch for the 3 epoch of the Simpo. So maybe yeah, in the future.
Okay. Okay, good. And if you were given one more week, what part would you improve to work better? Or which part
maybe,
are you not satisfied about?
maybe to finish around the almost 250 tasks. Maybe if I get that, and I will add the trajectory down control, and also there is a voice in the sameness. Also there is a multi-station isolation, and there's a AI should beyond that week, and maybe in the future I will do that on the shadow results.
Okay. Okay, great. And maybe do you have any other questions? I mean, do you have any questions?
I think we have. I just want to give other people chance.
Okay.
So I was also checking what you added to Hugging Face, and it says that it ran for 35 minutes. So did you try other alternatives as well? So you used Queen 2.5. There was also 3.5. And
yeah, but I was trying that. Yeah, I was trying that, but it take a lot of time, and there is a error showing me that. Because that I was downgrading the model to the 2.5.
Okay.
Yeah. So just maybe one question from my side is, so you have on the semantic, when you're talking about the correlations, you have the semantic less than 0.85. And that I understand that's kind of, you used some cosine angles. And that seems to me, so first is what's your view on that number? 0.85, is it large, small, negligible, or significant? And compared to the other, the Jacquard and others, how, what was like, what did you do to improve that one?
Yeah, on the semantic, the cosine is below around 0.85. That was I taking on the maybe linear length for the embedding. But I think the
Is 0.85, do you think 8.85 is large or small? Or
it's around medium, I think. For the electrical chip, maybe that was cosine below.
What do you think is large when it comes to cosine angles? Like if two angles are, if an angle, what's the cosine that is small? What do you want them to be?
Thing is a bit on the when you do the double leg on the composite on the embedding, I think that was the minimum threshold for that.
Yeah. So I'm just gonna tell you, like 0.85 is very large, like for a cosine angle.
Yeah.
So unless which, of course, it depends on which embedding you used in such a way that sometimes embeddings that there are no sentence embedders might just be averaging and too much. They are not sensitive, but for a sensitive, you want correlations to be very low. Of course, within, again, I understand your point. Your questions are a lot more still around sales, so they're correlated by a topic, but it should just be as well, just that their differences, their semantic differences, unless you expect them to be higher. So it's important to know the number. Like if you just show me it's 0.85 lower than that, I don't know what that means, like, because it's just is too large for a semantic difference. But if you studied, for example, okay, semantic differences that I have by hand have crafted, and they trace different things, and they are, in average, they are actually at around 0.85. And mine, now that between the training and the validation test, they are less than 0.85, then that makes sense. But as it is just the number, doesn't mean anything. The same is the job part, and the same is so it's important that you understand the context as well.
Yeah, maybe it depends on that, but it's not sufficient that one alone. I think to catch the paraphrase on the lexical check, maybe that one alone doesn't depend on that, I think.
Yeah. So I think so just that's one. And another one is how much of the jargons and how much of the things that you presented you can defend if someone really asks you, just and how much of it do you know them just in the past week, and how much of them you know them before. Hello?
Audible? I'm audible? I didn't hear you.
Yeah. Did you hear my question?
No, I didn't get it, I think.
Yeah, so like you presented different concepts that are related, simple and many other ideas and contexts, as well as the deltas and the hypothesis testing and all of that. How much of that is we were familiar before, and how much of that is that you just know about only from last week, and how much of that you actually understand them in depth, or like that means in more that you are able to explain if someone asks you in detail.
Maybe when we train on the jets, maybe that quality always has to train. But on the training, maybe it needs to predict that the latency and the read rate. So maybe the delta, that was the thing I get.
Okay, yeah, I think just in the interest of time, let's continue. Yes.
Okay. Damages, if you're ready to present, please just share your screen.
Okay, sure. Okay, I think my screen is visible, right?
Yes.
Okay, so hi everyone. I hope everyone's doing fine. And so today I'm about to present my recent project, which I've been working on the past week. So that is the TNHS bench, the latest agent benchmark, which is basically intended for evaluating sales agents. So let me proceed to the next slide. So
sorry to interrupt. Can you make it in slideshow view or presentation?
Okay. Okay, so we are good, right?
Yes.
Okay, so this is basically for evaluating how the sales agents work and the accuracy and the performance of the sales agents. So normally the generic agent benchmark is like Tau bench. They fail to adequately evaluate critical sales specific failure modes, and even the company specific style guides, or there are maybe other policies and the guides that the company wants to follow. So they normally fail on that. For example, in our case, we use signals to identify the companies or the prospects that we would like to work with. So normally in this Tau bench agent, it's failing on over asserting the weak signals, and even there is also overcommitment issue with it, and there is also tone failures. So let me make it quick. And so So the idea is, so I got these failure modes and how they are failing on the tau bench from the week 10 evidences. Also from that, there were mistakes in the policy boundary detection and identifying the critical points. There is also an issue with when transition between states or the agent is not properly taking the contexts and going. And there is also a coupling failures. There is a failure in during the scheduling, and then there is also instability issue with that. And then to address this, that the plan that I have come up with it, or as per the challenge that is given for us. So we thought that the result can be improved by training a model component that should be used on top of this agent. So it will be improving the result, the result of the agent. So for that, I built a data set with this percentage that's already given on the challenge. So 30% are derived from traces, 30% are from programmatical generate, and the other is from multi-LLM synthetic data. And then the entire training set is like 125. So the entire data set is like 250, and then so 50% is used for training, and the rest are kept for testing. So the path I selected for for improving this agent is DPO with LoRa adapter. This is basically selected to prioritize consistency over and safe decision making over just raw text generation. So basically, the problem is maybe there is also a problem associated with the text generation, but more the problem is with consistency. That's what I found from my week 10 traces. And so the target behavior that we want from this DPO is that it actually trains the chosen versus rejected behaviors, and this ensures and policy and the safe and the policy sensitive outputs. And so it's also good for faster iterations. So it's also an optimized approach for this kind of correct and right or wrong answers. So this is better when compared with the pass C and pass A for my context. And so how this trained model is used in the sales agent in real life. So the idea is the agent, the sales agent will be collecting inputs like the prospect context, the page summary, the request context, and the prior trades or conversation with the prospect. And then from that, you will be generating a draft. And then what will happen is that the adapter, the trained model will be applied, and then it realized and adjusts the output to ensure we are aligned with the predefined style guidelines and the company policies. So the final validation, so the validation that is that we run to check if the result is improved after the adapter is added is normally run on the final output that comes out of the adapter. So that way we can compare the result of the past, the agent alone, and the output from this adapter. And so what it improved is it has improved the grounding is, so everything that's coming out of the agent is now it has somehow it is grounded on the briefs that we already generated from the prospect data, and even the outreach is some more direct now. It is like a request or a follow up. So everything is to the point. There's no over complicating. And then even the commitment is there is an improvement on the commitment, like but it's not fully there yet. And then the performance is improved. And so the model, while evaluating the model on the 50 held out data set, this is the result that we got. So normally for the baseline score, the score is like 93.4, and for the prompt only is fully 100. It's 100. It's like a near perfect examples were given for that. And for the trained model, we got like 97.6. So the difference between the delta of trained and the base is like 4.48. This is on average, and the delta between the trained and the prompt is like minus 2.8. So still the prompt based one is outperforming. So these results came from the summation of those matrix that we defined for the tenacious tailgates. Those are groundedness and direct, and there are also other tools. So I will show you on the collab. And so there are still areas where we need to improve. So we have to improve the data set. I think the issue that I found mainly is the problem. The trained model is doing good given the amount of the training data and the pairs that I gave. But if I would have spent more time on preparing and refining the data set properly, I think it would be performing very well. And so that's it. Thank you. So let me show you from the collab. So first, let me show you sorry. Yeah, so this is the training loss over the various steps while training, and that I got. So first it was like 0.6969 something, and then finally it was like 0.03, and for the validation loss it was like end with 0.06. So I think the model was learning very well.
I don't think we're seeing.
Okay, sorry. I'm sorry. Let me share again. Yeah. So this is what I was talking about. I think my model has learned something given the data. So it was learning very well. So initially it was like 0.69. 0.069 first when it started, and then at the end it was like 0.03. So from that I concluded that the model was learning very well. So but what it was learning was not that much refined. I mean, there was something that I should have been working on the data set. And then so let me show you from okay, so I ran the one task through the model and just to see how it performs and the difference of the result that came out of it. I mean, the difference between after adding the adapter and before adding the adapter, when the agent just works on its own and after the adapter is added. And so the context is that it was given, the briefs are here. And so the result from for the baseline was like this. So on the directness, it is scored 4 out of 5. On the grounded, it is scored 4. Honesty, to give the data that we have, the bench that we have for developers is like only we only had like 7 data engineers, but it is proposing 10 engineers here. So so it is not honest, it is professional, it is non-condescending. And so when we see from the prompt only is 100%, and then for the trained, the directness is now a little bit went down. It is now 3, but it should have been improved. But for the groundedness, I think it has improved to 5. It is basically grounded on the data that it has got about the prospect, and then even the honesty it is improved, but it's not right still. But there is a lot of work.
Let's finalize, please. Run.
Okay. So I'm already there. Yeah, fine. So the aggregate score for the baseline and was like 76, but for this one we got 84. So it has improved, but it is not still passing. But if I more improve the data set and trained and I iterated over it, I'm sure this will be improved, and then this incident will be improved. So that's all. Thank you.
You're welcome. Just one comment from my end. I think it would have been better if you had the training loss graph right within the slide, and also if you had these outputs, the JSON outputs that you just showed us, in a way that's much more easy to present it. So if you have seen how Nuriye showed us, basically he had a front end and before and after. It's very easy to see what's there before and what's there after, and also it saves time. So when you prepare for presentations, as much as possible, try to make what you are trying to present within one area, so that we don't need to go through different windows in other places.
Okay. I'm sorry for that. I will improve. Thank you, Abdul.
You're welcome, It's okay. So if you have questions. Questions for the team?
I have a question, Abdul. Can I ask? Okay. Gamich, it is a very good presentation, but what I have seen is for Pass B, you have chosen a DPO for your to train. So, but on the other time, also you are complaining about the infrastructure. So why don't you just use simple, as it is simple and it's also very accurate if you have a good data set? I mean, why you choose that the DPO is more important than simple?
Okay, thank you, Nuriye. I think that's a very nice question. I think if you have attended the Friday session, I was thinking that I should be using simple. That will improve my agent's output very well. But during the discussion, Abdul was suggesting that it requires a lot of infras and a lot of data sets. So I should have a lot of training data, but I don't have the time for that. So that's why I didn't use simple. First I selected simple for my case, but due to the limitations, it's basically Abdul suggested that for me, and that's why. And yeah, I know simple would have performed better, but I think I'm still getting a good result with DPO. But even with this one, if I had more spend time on preparing the data set and the quality of the data set, I think I still could have got a better result even with the DPO. Yeah.
Okay. If that's the case, that's good. So one more question. In your data set preparation, you have made the shared datagram count and the cosine similarity, right? To test
yeah, of course.
How dependent the data sets each other, right? So after getting, let's take an example, if you get 0.85 or 0.8 cosine similarity between the data sets, what decision have you made to improve your data sets?
Yeah, of course, I haven't spent that much time on the data set preparation. That's what I was saying with the issue with the performance of my trained component. But I think if they are pretty much close enough, so I think that should be the case. They should be related, I think, somehow. Because we know what we are doing, right? We know the context is, and we know what we are expecting. And so I think if they are somehow very related, I think that's good. That is the expectation. We should get about 0.85. That is the target. So if I get that one, and then I was good with it. But I think I should have spent more time on the dataset part. So if you ask me what you should be doing next to improve it, what I will be doing is I will be iterating back to the dataset part and spending more time on the dataset. And I'm sure from that the train model will be better. Yeah, thank you for the question, Yuri.
Okay. Actually, our goal is just to make it minimal, the cosine similarity at least near to 0, just to make it clear. And thank you very much, actually. Thank you.
Okay, it's just one statement on the recommendations. How much is the recommendations was ORPO? It was not DPO. So yeah, simple needs to have a lot of preference pairs to be prepared. So just as a recommendation, I said Orco might be a better fit for this challenge, not DPL.
Okay. It's like after that one. Okay.
Okay, it's okay. So let's proceed. Amir, you can continue.
Okay, hello everyone. Okay, let me share my screen. Okay, so am I audible?
Yes.
Okay. So what we're trying to do is we're trying to create the judge for our agent, so that judge should be trained on data set, and we'll test that and try to make the agent more accurate for our purpose. Like we're fine tuning that. So okay, yes. So for when we're trying to use tau to bench, so it was scoring those things, but it's not accurate for our actual purpose. So for example, if we were asking if the agent, if it has 3 REST engineers, if it can deliver this kind of thing as a sales agent in tau to bench, if it responds like no problem, we can deliver 3 REST engineers next month, but so that it doesn't have any REST engineer in the bench, it assumes this response as a pass and as a correct. But from what we know and what the purpose of our agent, this is not actually something that should pass. So we're trying to solve this kind of things. So I created 215 tasks total from 33 failure probes and 4 categories. There's no contamination violation at all. So for each stages, I created 7 tasks from the enrichment, 16 from classification, and yeah, those numbers from each of those stages. And we have 4 categories. I mean, the signal grounding, the tone consistency, resource honesty, and workflow correctness. Those are the actual categories that we face failures. So from those, we created 215 tasks, and we check the contamination check by embedding similarity. Use Jacquard with 0.85 threshold. And we also did validity check for the tasks, schema validity, and like semantic validity. So
Amir, you have 2 minutes left.
Okay. So we have 4 authoring modes. So I think this is all in the instruction. So from this 4 authoring, we drive it. We created the tasks from this and make from each of this the numbers here. Okay, so I used the pass B. So because my agent has inconsistency problem, not generation problem, so that I use this one. I use simple, not over depot. So because of our T4 run out of VRM if we use depot. So and like it fits our collab T4, that's why I use simple, and the model I used is QN 2.51, 1.5B instructor. The model is simple. Yeah. So the honest finding I got is like for baseline, the pass rate I got is 34% with average score of 0.525 and latency of 0.00 second. There are no cost. For trained, the pass rate is trained. The trained judge pass rate is 30% with average score of 0.568. And yeah, the prompted one got higher, which is 58%, and the average score is 0.67. So generally, my delta is got positive plus 0.043, and for delta A, and delta B is negative minus 0.079. So yeah, all these things are live and public on the data sets on Hugging Face, the trained judge, the model, the community engagement, and the blog post. So what I do next is like, so I have only about 599 training tasks. I try to add more tasks, and so I just first test this thing with 377 pair of training tasks, and then I move to these tasks to 599. So I got like a great change in my delta A, as well as the p-value and also the accuracy. So it's almost the delta is almost double, and the p-value is almost halved. So increasing this data set actually changes the accuracy of my agent, as well as, yes. The other thing I will do is fixing distribution. So more of my training tasks are right now are synthetic. So what I should do is like, for each of these tasks or the probes I have, so I have to actually run them. Since I am using simple, so I have to run all of these tasks on the real agent and get the bad and the good results of them, and use this data to train the model again, and yes, try to increase that accuracy. Yeah, this is all.
Time's up, Amir.
Okay, thank you very much.
Just one question on the table. If you go back to the table, yes, here you have the pass rate and the average score, right? So what does the pass rate mean? And can you tell us how it relates with the average score?
Okay, so we have for each and every single task, there is a scoring, right? So the score is from 0 to 1, each and every single task. So we have a threshold of 0.7 for every task. If it gets the score of more than 0.7, it says pass. If it gets less than that, it says fail. So that is how the pass rate works. The average score is like the average score. The score is from 0 to 1. So it sum up those and do the average.
Okay, and from what's being shown, the pass rate for the baseline is better than the trained one, but the average is opposite.
Yes, like as I said, so the pass rate depends on the score, right? It should be greater than 0.7, so that it will be said as pass. So for example, if you have more of the tasks between 0.5 something and 0.7, not 0.7 actually, less than 0.7, so those tasks are not considered as pass, but they are good numbers. Like they can be greater than this average score, which is 0.525. Clear? Like, let's say we have 0.6 all, like all the data sets we got are 0.6. So the average score we get is 0.6, right?
What does 0.6 indicate? What does it mean?
Like, so for each and every single task, the agent scores them. Like, if we're using simple, right? So for every question or the task it gets, so this thing like it should be accepted or rejected, right? So if it should be accepted, it gets the score. It gives it the score, like score it, like the acceptance score or the rejection score. Score those tasks. So those are the numbers we have.
Okay, so 0.5 is the number of times it has been accepted.
Which one? This one you mean?
Yes.
This is the average score, yeah, for the whole tasks. The average number is 0.525. Yes.
It was accepted 0.525.
There are the accepted as well as the rejected ones. The average is this.
Okay, for example, if it said 1, what does it mean? So let's just scratch 0.525 and it says 1. Then what does that mean?
Come again, please.
So if we say the average score is not 0.2525 but 1.0,
yes,
then what would that mean?
That means every task got 1.
Every what?
Task is the score of 1, which means like the perfect answering, or for every question or the task we're giving it, it's responding perfectly, like the perfect response.
And okay, so what about for the pass rate? If we say it's 100%, what does that mean?
That means for every response we got the score of more than 0.7. It doesn't mean 1. It can be 0.8, it can be 0.9, it can be 1, but it's more than 0.7.
Okay, thank you, Amir.
Okay, thank you. Any other question? Can I stop?
Yes.
Yes, yes.
Thank you, Amir. Let's proceed. Jakob, you can continue.
Good afternoon, everyone. Am I audible?
Yes.
Yes, you are.
Okay. Can you see my screen?
Yes.
Okay. So as we all know, we have built last week. We have built a conversion engine for Tenacious. So this conversion engine was being evaluated by Tauto Bench Retail, which is an industry standard benchmark that scored 0.3. So that number was measuring the wrong things, like it could not detect banned phrases in outreach emails, or it could not check whether claims were grounded in real signals, and also it could not measure commercial safety. So the system was passing the benchmark and at the same time violating Tenacious standards. So I fixed that, which means this week's project. I fixed it with supervised fine-tuning in Pass A. So this is the result, which was Tenacious Bench version 1. In a 293 tasks domain-specific benchmark built for this exact system. So these numbers, we will get back to them in detail. So this is the problem I found. Tauto Bench retailed score 0.33 and could not detect any of these 5 failures present here. It cannot grade tone evaluation or signal grounding and commercial safety, none of them. So at the same time, when the results were generated on the last week, we can see on probe 16 and probe 17, there were tone drifts, like it was using banned phrases like top talent in some of the emails. And also there are other similar problems that were in the last weeks. So the conversion engine was completing tasks. It was also producing emails, but they were violating Tenacious standards. And the industry benchmark, which means the Tauto Bench, had no way to detect it. So this comes to the solution, which is Tenacious Bench, this week's project. It had 293 tasks and five machine verifiable checks and no human in the loops. So every task is scored by a script. Sorry, every task is scored by a script. The script reads an agent output and returns a number in under 2 seconds. So the benchmark was built using 4 authorizing modes simultaneously, 27% from real conversion engines, traces from last week's project, and 32% from programmatic ones, which means one program.
You have 2 minutes left.
Okay. Okay. So one probe becomes 20 tasks, and there are other ways to generate the tasks, and it will go through these 5 checks at all. So the result I got, the conversion engine baseline scored 0.491 at first on the sealed held out partition, and 57 tasks it had never sealed. So the trained LoRa adapter scored 0.754 with a delta A plus 0.263. p-value less than 0.1. That means less than 1 in 10,000 chance this result is a noise. So 95% confidence interval from 0.14 to 0.386. And we have a delta B 0.14 plus. This is a critical test, a prompt engineered baseline using the same model and the same style rules, but no training scored 0.614, which means the training adapter scored 0.754. Training beats prompt engineering by 14 points. So the honest gaps in recommendations I have. So one unresolved training failure. We have task B this. So the adapter generated a fabricated pricing claim. So that must be improved. So and if deployed one, we have these things. I think I am done for the sake of time. Am I audible?
Yeah. So I didn't. I was in a different place for other questions as well, for other presentations. But I'm going to ask you also then to summarize. And so, why do you get, or why do you think you get such a high lift compared to others who some got lower and some got higher? Where do you think is the? Is it in the training? Is it in the construction? What's your, like, when you, because you have now looked at other people's also work. So where do you think is like this differences, given that you guys are using similar approach, but the differences mostly, of course, are in crafting and also understanding, like, and the question generation and in the training aspect. But what's your understanding? How would you explain maybe the the potential source of variations are?
Okay, I can say, I think, two things in this question. The first one is, since most of what I have seen so far, most of my colleagues try to solve using the PAS-B, and I was using PAS-A, the ACFT, supervised fine-tuning. So this also makes a difference between the results, I think. And the second one is, of course, the training tasks when generating the training tasks, and actually using the training task to train the model. So the training tasks might make a difference. And I used, first of all, I generated one pair of tasks. And then for the second one, I improved the tasks I have already created using some suggestions I got from LLMs. Maybe if I answered it.
Yeah. So maybe Gamich and others like who presented, like, and who had also their improvements, how would you respond to like these differences? Do you agree that could be the reason, or do you sense, so do you have questions, or? Amir and others, like, who has done that, is the gaps or the differences in lift?
Okay.
Yeah.
So, okay, for me, I think the basic reasons of why my score is less is, so most of my training datas are not the actual, the real outputs we get from the what is called the agent, which means, like, so for since I used the simple, I have both rejection as well as accepted options, right? Alternatives, so that I compare and took. But those things are all synthetic. So I just generated it using the LLMs. I didn't actually generate it from the actual response of the agent. So maybe this thing, like the wording, the semantics that the LLM used, may not actually get from the the questions or the tasks that the agent gets. So maybe those things make a huge difference. I don't know. So for some, I see like having like 90 or 100% pass rate now. I don't know. Maybe we testing the same thing? I don't know. I have question as well. I didn't get how.
Definitely. So that's why I'm kind of opening just such that like you guys can at least agree that we're comparing numbers are similar.
Yeah. That's for me. From what I said, my biggest gap is that. So where I do the training tasks, they're not actually the real outputs I get from the agent. I think that is maybe what makes my agent less. I don't know. Thank you.
Yeah. Okay. Sure. Okay. So yeah, if there are other questions, great. I mean, this is good. And maybe one simple way is just like if there is a quick way that people can take on your own, like let's say Amir, just take the model that is fine-tuned and then just test it on your own pass rates. And then maybe just that could just be a simple check, whether just the model improvement has driven a lot of it. And I think one of the questions I have in general, and I think you guys just should think about is that so I'm assuming that you kind of fixed your agent and you're not modifying and optimizing your agent actually, right? So you're only optimizing your model such that the lift you were talking about is related to just only the model improvement. I'm assuming that's what we are talking, right? So in principle, just by simply substituting what Jakob's model to your model, can you get, do you get something similar? That could be just a simple check.
Okay, maybe. Jacob, you can share me your.
I think it's in Hugging Face. Yeah, just basically let's share the Hugging Face ones and just links, and you guys can try that. Yeah.
Okay. Okay.
Great. Okay, and then from my side, so we can continue.
Okay, should we still continue the presentations or move to the challenge
So.
introduction?
I think let's just complete it and then yeah, let's
Okay,
go to the next two.
Okay, Efrat, please to speak up and share your presentation.
Since Masarat also asked present next in the chat box, you need Masarat down. Okay, Masarat, how is it? Since she left, so okay, let's proceed with Efrat. Efrat, you can proceed.
Good afternoon, everyone. Can you hear me? Hello?
Seems good. Yes, okay, let's proceed.
Okay. So basically so today I'm going to present the signal force training a grounded B2B sales agent with preference optimization. So the core problems where we have grounded claims, calibrated confidence, channel discipline, and structured outputs. So these are the main core problems. And let me put this in the presentation mode. Hello?
Yes, we can hear you.
Oh, okay. All right. Okay.
So I'm sorry if my PC is a bit slow. That's why I was running models locally. So the reason we have this training on a narrow model is because generic models usually fail because they overclaim from weak signals. There is also incorrect qualification. It also ignores exact output contract like JSON only response. And we also have a kind of discipline, especially around pricing and booking. Sorry. So this is a system architecture. So we're using the ORPO with LoRa, and then the model version we're using is Coin 3.5. So this is more of a generic presentation. So the ORPO has lower complexity and stronger for choosing for choosing and rejected data sets. So we can have like two or multiple choices. So this is a prompt. This is the correct way to do it, and this is the rejected answer. So that's why we're using ORPO, and then we're also using Anslos. So which is why we can run it on Collab, and it also enables us to use 4-bit workflows. And then the model is Queen. So this stack was chosen for repeatability because it can be reproduced by other teammates as well if needed. So, okay, you know what? I'm sorry, guys. Let me switch to this up and let me run it. Okay.
If not, I think maybe we can come back to you. If it's not, maybe if it's internet or your PC is not responding, so let's come back to you. And Masarat, if you are here, you can proceed.
Yeah, I'm here. Sorry, guys. Is my screen visible?
Yes.
Okay, thank you. Good afternoon, everyone. Sorry for the delay I made. So on this week, we were trying to build the benchmark train race, and we were working on the models and then prove them to get meaningful and better performance for the B2B sales task. So here I will try to show you the overall result I got. So first, after I turn the AI model specifically on the B2B, the outreach failure improved it by 25%. So the tasks had never seen. So those tasks are improved with this percentage by Depot. I used Depot because of it's kind of stable and then simple to use, and also it's computationally efficient. And then I ran this with 10,000 statistical reassembles to validate the result, and it's almost zero because it was testing it for improvement to be zero, and it got literally 0. And this is the cost, overall cost, almost 0.67 cost is kind of efficient. And the amount of data task is like, I trained to 238 tasks, and for the 159 for trained, 52 for the held out. And the 0.91 Kampa is like for reliability score of our rubric, and it's kind of the industry standard for almost perfect. And I will show you the exact where it states came from, and I will show you the whole system running live. So the problem we had was like we need to show that the gap we were solving. So because the benchmark choice were most AI evaluation goes wrong on the week 10 because of those reasons. So the three main failures was signal hallucination, over commitment, and then tone violations. So the problem the tie squared was like most of the campaigns we have been using were like cited like almost 2K tasks, and those even if they are using that like with the company like IBM and kind of those companies, it wasn't like based on the order. It wasn't looking for the performance based, and also the it makes judging calls based on the remorse or like not signal real signal calls. So that's why those those three failures I made was the main things we have to focus, and that was based on that I worked on this. And the solution was like mainly I focused on the signal confidence ICP segment, those as you can see, and overall I used 30% for LLMs synthesized and handoff output for the 10%. This is my trace for the from the week 10, and I can show you the just overall email how it's rated. For example, this is one of the good emails, so it was score is at 1, like as a 1, and also if I show you the quality, if it's less than 0.7, it will block it because it's kind of the email is not that should not be sent to the company. So that should be fixed, and if it scores 1, it will change it and there will not be any block. So for example, like one phrases like top talent, those common email sends, so we have been seeing that. I hope this email finds you, like those kind of stuff should be failed and should be blocked from the before they send. And then yeah, this is the rate among the if there is any it is 0.9 because it's kind of there is no booking link, and if there is over commitment it should fail. And those are the like the overall rates that should block from the email. So this is our outreach pipeline. So first the on week 10 production, we have been saying like we have signal enrichment, right? So and also we have ICP classification that should be traced on the language, and then the email composition with the quality gate. Like as I said, it should not be blocked if the rate is more than 0.7, and then also it should track to the call and email traced. So this is overall result for the results. Like it improved almost 25.4%. Like with the model I used Kin3 1.7b was not training. Then it held out the range of this. We don't just give the point estimate. I just give it the uncertainty, and then we look at 50 for 52 the pairs I used before and after scores, and then this is the bootstrap I used for the 10,000 resemblance, and this is the overall probability that I showed you. And the beta B result is like delta B, sorry, as it improved with 0.11, but we observe that depot wins because we know that training is necessary, even if we have prompting, although it will most probably will fail, and we'll have to take care of that. And then This is the overall training run, how much I tried. So the cost is like I tried to mention before, it's almost 0.67 cents, and is efficient, and we can is for the budget wise, it's kind of preferable. And yeah, this is my risk control overall, and yeah, try to achieve this.
Maybe, okay, yeah, maybe I will ask later. Just don't worry, just go on.
Okay.
You stopped your presentation.
Yeah, sorry.
So you stopped your presentation. Were you done?
Actually, I'm done. I was just trying to run those quality gates. Yeah, that's overall I have done so far, and I think for the next improvement, maybe I should work on the more task. I have to train more tasks. Like I almost or I only train 230 tasks, and I might go further for the number of tasks, and also I might use the other modules for the most improvement part. Yeah, that's what I got.
Okay. Yeah. So maybe mine was related to cost. So that the cost seems too small.
Yeah.
And is that just because, like, in terms of like your prompts and the agents? So when you say like 10,000 samples,
yeah,
and roughly I'm kind of expecting how many tokens are there just overall when the agent is kind of analyzing something. And then when I multiply that one 10,000 times, at least for some of your tests, I'm kind of, so where is the, which cost have you measured actually? Like, is it the end to end? Is it in the, which part is like that 0.0 something only dollars?
I think it was like my tasks were like 230, so it wasn't that much to cost like more than 0.6, and I might say my end to end was kind of that doesn't
per one task you have prompts, you have like the system prompt, that your user things and your ICPs and your every other thing, which I imagine takes more memory or more context. And now I multiply that one by 200 something tasks to try to solve. That's one. The other one is you also measured some things 10,000 times, right? You've sampled like, and you also measured your stability, your rubrics stability, that also needs some form of like redundant checks, right? So are you actually summing overall, or are you just actually just for one? Is that a cost for one, or is that a cost for everything?
Like the total estimate project cost is like for the benchmark construction, so I think that for data synthesis, and then also for the model training. So that's overall the cost.
So is that number for other people? Is that number reasonable? Have you looked at your number? Because I kind of, seems to me like normally even 0.141 email sent, it still is good, let alone for just the training. So it's kind of, I'm much more interested to see what's the cost other people have, what's the cost that other people had. Is it something comparable or quite different?
Like it seems kind of not visible, like visible to God, this kind of cost. But for my overall project, that's is what I got. I think I have to refine.
So I'm just more asking other people as well. So is your cost, like anyone who has done, is your cost similar? Have you looked at your cost?
Can I ask you that? You mean like I have
this
to
is more for other, like it's just okay, like yours is clear, but I'm just asking other people in the cohort who has presented, what's your cost?
Can I ask you? Sorry.
Yeah.
Did you expect that our cost to be higher than this? For the, yeah. Okay.
Yeah, exactly. I mean, that's too small, because I mean, I'm just kind of like a million token. We know how much it costs, and then I know how much what one agent, when it's trying to synthesize, it does lots of things. Unless it's not doing anything, my expectation is like this seems to be too small, given like, so maybe the question is that, okay, QA in just that part is so small that there's no cost associated because you guys are actually using local models and it's fine. It's only just that. So in that case, I understand. Okay, so then you are saying that all of your inferences are done locally, so there's no cost associated to it. But it is fine for that. But if you were to deploy it, I think maybe presenting in this case of cost at that level is a bit misleading. I mean, I understand if that is the case, but the cost should be normally calculated per token. So instead, if you were to present the number of tokens overall, then that would give you an actual cost given, okay, if this was like, let's say cloud, if this was Gemini, then you'll be able to calculate. If you had also not only the cost, but also the token, the number of input and output tokens.
So I think if that should focus based on the tokens, it should be
normally. I think normally the standard is token, right? Because cost is very much variable. Like that cost is multiplied then afterwards. So unless like the other cost that you have to report it more is GPU cost. That's kind of like an hour in GPU, right? Or like that kind of thing is fine with actually, but even just if you just say like a cost for that, but the actual part, if it becomes like tokens, almost always tokens for any agent work or any LLM work, the actual currency is token, not dollars. Dollars are then converted by multiplying based on, okay, if I use this model, then the cost will be, the USD will be this one. So I think now I got it. Okay, I'm not surprised because almost all of your run has happened locally, right?
Yeah.
Okay.
I think that's it.
Okay. Okay, then that's clear. Okay. Great. I'm done.
Maybe to add here.
Yeah.
Yeah. There are four kind of data set generation actually. So one is using multi LLM based data set generation. So that may be one part of the cost that we have to consider, but the other is during training, during testing, everything they are local, so there is no cost at all. It's almost zero. For me, actually, it's zero.
I understood. I think now I got it. So sorry, I was just slightly confused because that number, I was expecting it only just for one good email send. That's probably what would be. So I think that's, yeah, but it's fine. So I think it's clear. Let's continue.
Okay, so I just have one question. So did you run your Week10's agents on the new benchmarks that you are running for the Week 11? So in Week 11, you built basically you trained, you fine-tuned the model so that it performs well given from the benchmark you extract the training data set and the test data set, right? So if you are comparing the two, since on Week 10 you used Tower Bench and not Terminal, not the Tenacious one, did you run it on the Tenacious benchmark and then you compared that as a baseline against the fine-tuned, the Coin one?
Yeah, mainly you suggest to you the benchmark baseline, right? Maybe it was there. So I just do that comparing with that, and then against to the Week 11s I have made.
Okay, so how was baseline computed?
Like based on what?
So you have a baseline, a score. So you are comparing two things. You have a baseline, and then you have your own fine-tuned model, and then you are comparing those two to have a delta A, right? So how is the baseline computed? So for the fine-tuned one, you are running it on your benchmark, on the benchmarks that you have produced, which is the tenacious bench, and you have the train and test data sets. But for the baseline, yes.
Maybe if I'm not mistaken, like later on the trace logs we had on the week 10, and so week 11 use that, right? So for that purpose, was like basically from the week 10 I have trace logs those results and the score I got, and that's I think I did.
Yes, but that's from the tau to bench, right?
Yeah.
And not from the tenacious benchmark that you did this week, not the past week.
I think so.
Yes, so it might not be like apples to apples comparison.
Okay.
Now I'm even more confused because I thought you would answer this one in a very natural way. Have you computed your baseline not based on the unfine-tuned model, and then you're comparing with the fine-tuned model? Because I think earlier when Yaakov was presenting, or I think others, I'm not sure who, that's what clearly I heard, and that's what's supposed to be done, right? So you have whatever model, QN, unfine-tuned, like the baseline, like that's what's called baseline. The results that you get, the scores you get on your held out data versus now fine-tuned on your held out. So it's the only change is that what makes it a baseline is the model change, not any other thing. So how did you, I think, just explain to me exactly what is your by baseline, how you compute it?
Okay, so we have a baseline traced for the week 10, right? I think I made a mistake. Like we got a baseline from tenacious, right? You gave us, and then I tried to run those logs from that, and then from the results I got, I tried to get some results, and then it compared to the week 11. I think if I got the answer.
So, okay, so that means if you get, so that model for week 10, you were using a different model, right?
I wasn't using Queen, like I was using other models.
Exactly. So you were using other model. So your improvement on training is so you improved, but that one, you're not running, like, I mean, I think in that sense, maybe it's just our writing in the challenge document. Then you're not, the baseline is, it's much different now when it's compared. So how many people have done that versus how many people have done actually just when they say baseline, they mean that the model without training versus the model with training. Like just maybe that, has anyone done that actually? Like is when they say baseline, it meant the one without training versus with training, or is everyone using baseline to mean the score you get in your week 10, just whatever score you got in your week 10? So which one is it? Just so Nuria, you said thumbs up. So which one is it?
So the baseline is without training, but the full run is with fine-tuned training.
So it's on the same held out data.
Yes, yes.
Okay. I think that's what makes sense. So in general, whoever has done differently, maybe just the easiest to check is that I think you can check it because it's local, so it's fine. You should just compare your agent's performance with the unfine-tuned QAN 1.5B versus the fine-tuned QAN 1.5B, so that you now have on the held out data, so that you have exactly like comparable results. So they both, so it's just basically then measures your improvement on the base model, like or the LLM model.
Yeah, actually it have been clearly labeled on our challenge document for ablation test, which is the delta A test. So that's where you said.
Yeah.
It's just similar to the giant document. Yeah.
Okay. Yeah. So Masarat, then I think that's maybe just run it now, and then by the end you can just type it because I think it's easy to run. So, but is it clear for you what we're talking?
Yeah, it's clear. Yeah, it's so clear.
Yeah. To you, Abdulhamid.
Okay, thank you, Masarat. Let's proceed to Johannes.
Okay, how are you, everyone? Can you hear me?
Yes.
Okay, so I'm going to share my screen. Okay. Okay, so I'm going to start my presentation. This is the Tenacious Bench version 1. This is the dashboard I built to evaluate the B2B sales AI agents we built last week. I also have a presentation slide prepared, but I'm going to stick with this for the time's sake. So this is the first page, which is the dashboard. The headline numbers are at the top. Train LoRa pass rate is 85.4% rate. The baseline, which is no fine tuning, no prompt engineering, is 33.3%. And the plus is 26.4 percentage point lift is what training bought us. And on the left, you can see all 10 failure dimensions. Each one is a specific way the agent can lie or mislead the prospect. Signal overclaiming, bench over commitment, tone drift, and so on. So at the bottom right is shows exactly why this benchmark exists. So the tau square bench looked at some trace and said pass, and an email was sent, but the Tenacious bench said fail. The agent wrote rapidly scaling from a signal explicitly labeled weak. That failure is invisible to a binary scorer. So for the second page, I'm going to show you the live scorer. So I can select any task from the 71 task dev set and score an email against it in real time. So I'll pick a signal overclaiming task here and a random task like this. So as you can see, the confidence is low. The company is Flux Engineering and 200 days old. Open roles found, and the instructions say do not assert aggressive hiring velocity. So let me load the failing email. So this is the kind of email the week 10 agent was generating. Look at it. So it says aggressively scaling, rapid hiring velocity, and deploy 3 senior engineers immediately, all invented from a signal that had 0 open roles and was 200 days still. So let me score this email. As you can see, the score is 0. The score is 0 failed. The score is fully rule-based. No LLM runs in under a second. And the reject negative checked fired immediately because aggressively scaling is a banned phrase when signal confidence is low. And the rejects positive is still passing. So let me load the passing email, and let me score this one as well. So it's the same task, but different email. The score is 0.6, but it failed because the threshold value is 0.7. So for the third part, let me show you the ablations results I got. So ablation results, 3 variants tested against 48 sealed held out tasks, and the baseline is 33.3%. Prompt engineering only is 41.7%, which is plus 8 points. And trained LoRa adapter is 85.4%, which is plus 26.4 points. And the confidence interval is 18.7 to 32.8. It does not include 0. So the lift is statistically significant. So this is the bar chart at the left. shows 3 variants side by side, and right chart breaks it down by failure dimensions. So all the BOC, DCC, and those types are all 100%. The ICP at 83, the signal over commitment at 67, and SR at 40%. The 7 radial failures are all in SR and signal over commitment. That tells us exactly what to fix in the next version. So this chart is the adapter shows the inference speed, and the adapter is 3.2 times faster at inference than baseline. So for the last part, I'm going to show you the evidence chain here. So every single numeric claim in the README traces back to a source file in this table. No numbers were written by hand. I can search for any claim. For example, let's search 85.4 here. So as you can see, there is a train LoRa adapter pass rate, which is 0.8542. The source is the ablation results, and I can search for anything. For example, let's search SR here. And SR dimension pass rate is 40%, points directly to the held out traces.jsonn, filtered by model variant and task ID. So the full raw results file is at the bottom. Every number is reproducible from the JSON-L files in the repo. And for the final part, I'm going to show you the community engagement. So the data set, the LoRa adapter are on Hugging Face, and the blog post is at Medium and Substack, and the Tau Square Bench issue is submitted in to this link, and the license is CC by 4.0. So everything is public and reproducible. Thank you so much. That should be it.
Great. Yep, I think that's good. The one thing that I'm confused is on your timing. So when you showed us the timing, the LoRa adapter seems to be smaller in terms of, are you testing on the same resource, like just the same collab? And then if so, because my understanding is that, are you quantizing for the LoRa? Is that the reason why you have a smaller latency? Because otherwise you are adding still the base actually is used. So LoRa is just basically adding an additional like matrix addition to it, to the base. So inference should increase, not decrease. So what's going on? Johannes, is that clear?
I'm sorry, I muted. Can you repeat the question?
So if you go to your latency on inference time.
Okay.
Yeah. So inference speed, so collab. So the baseline, your baseline seems to be much larger in terms of speed versus LoRa. So what does that mean? Because LoRa is adding on top of the baseline, and then also prompt engineering, I'm assuming, is that are you using, like, is that because of adding the tokens, the number of input tokens, why this is decreasing? So I kind of don't understand what's your baseline latency, why prompt engineering reduces it, and why train LoRa even further reduces it. What's going on?
Okay, so for the inference speed part, the baseline is actually, I'm sorry, I cannot answer that question.
It's okay, just check it. Yeah, because maybe that your number baseline, this seems to me reverse it in one side, because then baseline is supposed to be maybe just a smaller, and then as you add more matrix multiplication, but the addition of LoRa is fine, unless you are now quantizing and kind of reducing. But then also prompt engineering in principle from the baseline it should add more examples and stuff, right? So it's prompt engineering will add more inputs, so it should be higher than, like basically higher than the baseline. So I think something is wrong. Check it and convince yourself.
Okay, I'll be sure to check it out. Thank you so much.
Thank you, Johannes. Let's proceed to Joseph. And Joseph, continue.
Okay. Okay, so I have a short presentation. So okay, am I audible? Okay. So I have chosen pass B, and so the problem was misclassification of the ICP and exceeding words, and the fabrication of the funding round is from the pass one on the top bench. So to try to address the gaps, my approach was a preference tuning judge on the pass B to add a cell layer and for LoRa adapted judge to be trained. So this was my data submitted. The partition was 50, 13, 22 held out, and the task generations are from trace, programmatic, multi-lim, and hand-curated. So the preference data sets are around 266 validated, which have the chosen and rejected pair, and the gap between the two are almost in the 3.7. So these are my pipeline. So first, I ran the generated pool, which I got 331 for each type of the task generated. But after using the LLM mass edge gate, it reaches to 249. So how does the LLM mass edge gate is based on this scoring of 1 to 5? First, it's contain the input coherence scoring, which scores like if we are hiring 10 people, and also if we say like we are hiring 50 people, it will score less, and the ground truth is if it's verifiable and the rubric clarities. So this is how it just and to prevent leakage, I use DeepSeek-3, for example, to get chemistry outputs. So I've gotten here. I've gotten here the around the 14 pricing, and the last is embedding the data. So here I use a cosine similarity using which are if they are more than 0.8 to remove them. So at last I got around 217 tasks. So here are the duplication preventing model from overfitting. So I remove that. If they contain identical sequences on the generated, so I remove these overlaps and also the embeddings. So this is one of also the things I've done. And at last there is a contamination test between I have the train and the held out to see if if it has contamination. So on the held out test, it's contained at 20%, and so these are the 39 unit tests. So this was my result. First, based on the agent, I got only 2.8 5-6%. This is from the 39 tasks. I think it's 1 or 2 tasks only pass, but after I meet the judge assay layer and run it, I got 29 out of 39, which is the 53.5 percentage. And this is how is the scoring works. So how this delta percentage pass and fail works is based on the scoring of point-wise scoring from 1 to 5. These are the hard fails. If this fails, the task already failed. So these are the 100-word limits and the missing booking like the CTA and using the band high force. This will fail. And great dimension, the signal grounding, the donut errors, and the bench calibration in the accuracy based on the scores. I got the scoring and assay requirement is from 5. If I got 3.5, that's going to be pass, and if it's less than it will be fail. So I think this is progress. Thank you.
Okay, Joseph. Did you train a model? Did you fine-tune?
Yes, I fine-tuned using but I did it on last, but I used the DPO. I tried to the simple, but it failed me, and at last I used the DPO. So that's
okay. And did you use the fine-tuned model to basically judge the outputs?
Yeah, these results I got from these results are when I run it on the core lab using the fine-tuned model and download the traces, the jet traces, and I run the script on locally to score. That's how I did it.
Okay.
So I think it's kind of, the reason is it's confusing the way you said it. Trained judge recovery. What does that mean? What do you mean by that? Do you mean, I also so confused. Does it mean, I don't know what, like, so baseline, I'm assuming you have the 39 ones and then it failed. So the baseline is basically the baseline model, the unfine-tuned model.
Yeah.
And then this one is a fine-tuned model now substituted to your agent. Is that the case? Is your week 10 agent with the unfine-tuned model is now failing at basically
that
I
used the previous my previous agent as a baseline, and this one is from
as a baseline. So agent and model are different. So I want to really make sure that is clarified. So your agents are the same. Are you now, when you say baseline, are you replacing the model that the agent uses, or what are you doing? Like, just what is baseline?
Yeah, my baseline is the previous week's model without the judge layer.
I don't understand.
Okay.
So just make it clear. So you have an agent. So the things that we're talking about are data. You have now a data. This is the bench. And then you have a week 10 agent. An agent is a combination. An agent is defined a model plus a harness, right? A model is, you can replace any model. You can use cloud model, Gemini model, QN model. Now, so that plus a harness. Harness is whatever you build in terms of like how you construct your context and stuff. So then now for week 11, what did you do on top of that? So that's what you were left, and now you have prepared data set. Now just tell us exactly this number within that context.
Okay, so additional to the QN 2.5 baseline model, I fine-tuned the model to understand the accepted and rejected differences. So based on the fine-tuned model, I got this score, if I understand it.
What is the baseline and what is the train? So let's call them your QN that's not trained, that you just downloaded. Let's call them model A.
Okay.
And then the one you fine-tuned based on your bench, tenacious bench data, let's call them model B. And then you had your week 10 agent. So just tell me what is baseline here, what's trained here, just within that.
Okay. So what I did was, for the baseline, I used the Quaint 3 model. Okay, yeah, to clear, I didn't use the week 10 agent, but I for this course, I used the Queen the model without the fine-tuning model, and I got the 0.25. But after using the bench, the data bench, I improved the score. Yeah. Well,
Yep.
okay. If
No
I didn't,
no agent, it's just more a simple chat.
yes.
Okay. Yep.
Okay. I will dig deep after it. Okay. Thank you for your suggestions and comments.
Okay, thank you, Joseph. And I think maybe just to add one point. So, Joseph, I think what you did was you already have an agent from week 10, but for this case, you used a Queen model as a base model. And then you tried running it on the benchmarks that you have created. And then it scored 2.56% on that benchmark. And then you fine-tuned a judge model according to the PAS-B selected. So the PAS-B would say have a judge model in between, and it will see what the agent writes, and it will basically say, I will accept it or not accept it, and it gives out a reason, and then the agent would say, take that as an input and provide an output that suffices what the judge has provided as a reason, and then based on that, you got a 53% on the benchmark. So with the judge, you improved your result from 2.56 to 53%. Is my understanding correct, Joseph?
Yes, that's what I did.
Okay, so you basically fine-tuned for the PAS-B, you fine-tuned a model and it acts as a judge.
Yes.
Okay, understand that. Thank you, Joseph. Masarat, you have a question?
Yeah, like Mr. Yabawal was saying that for the costs, basically it's because of the locally we got this kind of amount, like almost 0 cents. And what would the other option though, if it's not locally, like what was the cost can be?
No. I think it's token. Just even locally, you can count token. Just count the tokens that flow in and flow out. Then that will just tell you in any production, then instead of reporting it by dollars amount, you say, yeah, like I consumed for training or for this, for that, I consumed N number of tokens of input tokens and M number of output tokens. With that, you can almost always convert to dollar amount. Because agents operate, or any LLM work operates, whether locally or on a cloud, they operate. Their currency is token, not USD. USD is then converted by some multiplier.
Yeah. Okay. think.
Okay, I think we had probably was that Efrata who was trying to present and couldn't, but it seems like he's not here. So in that case, I think we are just done. So I'm going to be also very short on the challenge for this week. So let's just take a break, just only 5 minutes, and then I will come back, and then I will not